Oh, we are the Ask Academy. That's right. Feeling it tonight. We're going to be talking pre-calc. Two more concepts. Average rate of change. And even or odd functions. What do you think? We can do this, right? Yeah, that's right. We can. So again, in pre-calc, that's what we're doing today. We're going to look at pre-calc and we're going to look at average rate of change. As we look at that, I'm going to try to do this where you can see this on the video. Average rate of change. So really the words that I'm going to talk about with this is what we're going to be doing is when I have an app on my smartphone, and that app is something that I use when I go out and work out. So I can enable the GPS, I can start this, and what this app will do for me in my smartphone is I have asked it, and it does the mathematics, to be able to calculate the average speed or the average rate of change. Now when I'm running, I don't run the same speed all the time because I get tired or I have to go uphill or I have to go downhill. My speed changes as I run. Well, that average rate of speed is calculated by what we call a secant line. And it takes over an interval of time in my run, for example. I could be my distance in my time or my speed over a certain time could look something like this. I'm running along and as time goes on, I'm faster, faster, faster. Well, as my speed gets greater, I may be going downhill and then I get to the bottom of that hill and start running uphill and my speed decreases. Well, average rate of change, and this is what the app does for me every quarter of a kilometer, is it takes a secant line over a couple of points over that, and it averages the speed over this interval of domain from this value to this value. Really what it's doing is it's calculating that slope of that line. So that average rate of change formula is going to be finding the function value of it at a point x2, subtracting the function value at a domain value of a point of x1, and then dividing that by the run. That should sound very familiar. The difference in the x2 to the x1. If I subtracted this way with function value, I've got to subtract the same way with the domain value. Rise divided by run. It's really the slope, but you're averaging that rate of change. You're averaging that, for example, a speed when it models that in my smartphone app, when it's averaging that for me. So as I'm running along, I have my earphones and I'm listening to my music, and then when it gets to a certain point, the phone app calculates the average speed and gives me my current speed at in that particular interval. What was my speed average over that interval of time, or whatever unit that I'm asking it to evaluate over that distance, or whatever the time is. So that's what we're going to be learning to do today. So we're going to be given examples where we're given values for f2, f1, or we're given a function and we're saying over this domain interval from this domain to that domain, or this domain to that we calculate the average rate of speed, or the average rate of change. So that's one concept that I'm talking about. It's the last two concepts in this particular section 1.5. The last one is a concept we call odd or even functions. If you're given a graph, how do you tell if a function is either odd or even? One of the concepts is looking at the picture of the graph, and if you're looking and you see symmetry about the vertical axis, the y-axis, the f of x axis. If we have symmetry there, and I'm showing you the graph of this, if you fold right on the vertical axis, does the graph fold right over on itself? The answer is yes. Then that means it is an even function. An even function has symmetry over the vertical axis. Now an odd function, if all you're given is a graph, if all you're given is a picture, and it looks something like this, you saw that that function, as it was graphed, it's not symmetrical over the vertical axis. If you fold it over on itself, it's not going to match up over if you fold it on this line of the vertical axis. But if you do notice, what does have symmetry though, if you stick a pin right there in the origin and you visualize turning that, if you turn it 180 degrees, or you turn and rotate that around that point to this, and then at the same time that's going to go up there, that has symmetry about the origin. So, functions that you see the picture of, and it has the ability to be able to rotate, and within one revolution it gets back to where it looked like it started. That's an odd function. Okay? So you have two bits of symmetry. You have symmetry about the vertical axis, and you also have symmetry about the origin, even and odd. Now, if you don't have a picture, but you have the algebra of an even function looks something like this. The function value of a negative domain is going to equal the function value as if you had plugged in a positive domain. So a function is even if when you plug in a negative, you get the same answer as if you had plugged in a positive. So an example of that would be if I have a function that looks like x squared. If I plug in a negative 2, I'm going to get negative 2 squared, which is 4. Negative 2 squared, which is 4. But if I plug in the positive 2, positive 2 squared is also 4. I get the exact same answer whether I plug in the negative of the number or the positive of the number. That's called an even function, and it has symmetry around the vertical axis. Well, for it to be odd, there's also an algebraic test. An odd function says this: if I plug in a negative value, a negative domain member, into that odd function, I'm going to get exactly the same